Hello, I'm Haoyang Leng, a graduate student in Material Science and Engineering department. Today, my presentation topic is the influence of the BCPS molecular behavior on the structure color of the 3D printed PC objects. My presentation will include 4 parts. The first part is the background introduction. We live in a colorful world and always feel the colors bring beauty and pleasure. There are 3 main sources for nature color, including pigments, bioluminescence, and structure colors. Structure color is a special one, which is the color produced by micro or nanostructures, and is usually bright and dazzling. The picture on the left side shows you some structure colorations in nature. Although a vast brilliant colors can be produced by using dyes or pigments, many such colorings are actually based on heavy metals or toxic molecules, which is not environmentally friendly. So some other methods are required to be developed to address these issues. Additive manufacturing as a creative manufacturing technology has attracted people's attention. So one approach is try to integrate the structured color into 3D printed objects to get the printed objects which can process structured color. There are many benefits for this approach. It has higher production rate, controllable properties, less material waste, and more environmentally friendly. The second part, I will try to discuss the 3D printed PC objects. At first, the self-assembly of BCPS to nanostructure material processing of photonic band gap provides the potential solution through the bottom-up self-assembly of materials. However, the inherent characteristics of the micromolecular chain entanglement introduce an energetic barrier for the self-assembly to other nanostructures, which can prevent access to visible light PCS. To get this fundamental property, the design and synthesis of the micromolecules with rigid road characteristics is necessary to reduce the capability for chain entanglement, which can allow for rapid self-assembly to PCS. Molecular brush and dendritic compolymers composed of sterically bulky repeat units can limit the potential for chain entanglement and have been successfully synthesized by an approach called reopening metalysis polarization (ROMP). ROMP is a robust and efficient method for the synthesis of such dendritic BCPS. It is estimated that the dendritic BCPS can possess the potential to self-assemble to visible light reflecting PCS under the condition of FDM. A dendritic BCP composed of the benzyl and alcohol which type monomer was synthesized during the ROMP process. After that, this dendritic block copolymer will self-assemble to final photonic crystal. Interestingly, for the isolated ensemble BCP, it was colorless due to the lack of other nanostructures. During the filament extrusion, the BCP will self-assemble to a nanostructure material, possessing photonic properties reflecting violet light. The picture on the right side shows the 3D printed butterfly's wing in a flexion and transmission mode. So the results told us the dendritic BCPS can successfully self-assemble to visible light PCS in FDM printing process. The study also investigated the influence of the molecular weight on the domain size and reflected light wavelengths of the final printed PC objects. 3 BCP samples were synthesized on multi-grain scales through the RMP of the equal mole ratios of the two monomers to produce the BCPS with molecular weight of 581 for BCP1 and 876 for BCP2 and 1130 for BCP3. The bulk BCPS were then extruded into the filaments for the 3D printing using FDM. The SEM was applied to visualize the nanostructured morphology of the cross-section of these films after freezing fracturing. For the films made from BCP2 and 3, the normal morphologies were observed, which are correlated to the observed reflection of the films. Interestingly, although the film from BCP1 efficiently reflected violet light, the observed morphology was not a non-manners morphology, but a spherical morphology. As to all the 3 filaments, spherical morphology were observed, which is pretty similar to the PC thin film produced from BCP1. All the filaments can possess the photonic properties and reflect violet, green, and red light when using BCP 1, 2, 3 respectively. The picture on the right side shows you the 3D printed PC butterfly by using BCP as 1, 2, and 3. These 3 samples can reflect violet, green, and red light respectively. So based on the study, it told us the reflected light wavelengths of the PC can gradually increase as the BCP molecular weight increasing. Also, the centimeter-sized PC objects with a 3-dimensional geometries can be manufactured successfully. For the summary part, first, the dendritic BCPS can self-assemble to visible light PCS during the FDM. And the dendritic BCPS can reduce the chain entanglement. Second, the molecular weight of the BCP can influence the domain size of the self-assembled nanostructure. Then, the domain size of the self-assembled nanostructure can further influence the reflected light wavelengths of the PC. The third part is the application of the 3D printed PC objects. This picture shows you the model of the polymer-based PC acting as the light guide. A hollow U-shaped tube was printed from BCP2. It is estimated this geometry can serve as a frequency-selective light guide. When a white light was introduced into one opening, only the green light can exit the other opening. So this experiment actually demonstrates the feasibility of these printed objects in a more by using these 3D printed PC objects in more advanced optical device or circuit application. There are also some other 3D printed products in full color. So 3D printed piece objects actually have broad applications, ranging from aesthetics to communications. And based on the study, the 3D printed piece objects can potentially serve as a frequency selective light guider. The last part is my future research plan. In the future, we can also investigate the possibility of applying the 3D printed piece objects in advanced optical circuits and devices field. And also, we can try to investigate the influence of the processing parameters in FDM process on the optical property of the 3D printed piece objects. Thanks for your listening.